introduce Dr. Amit Kumar Yadav to you all. Dr. Amit Kumar Yadav received his BTech in 2009 from Uttar Pradesh Technical University, Lucknow, India, and MTech in 2011 from National Institute of Technology, Hamirpur, Himachal Pradesh, India. He earned his PhD in Artificial Neural Network-based prediction of solar radiation for optimum sizing of photovoltaic systems for power generation in 2016 from National Institute of Technology, Hamirpur, Himachal Pradesh, India. He served as a faculty member at the National Institute of Technology, Sikkim from 2015 to 2023. Currently, he is a faculty member in the School of Computer Science and Artificial Intelligence at SR University, Warangal, Telangana, India. His research interests include artificial intelligence application in energy systems, condition monitoring of photovoltaic systems, solar and wind resource assessment. He has supervised more than 20 undergraduate projects and 2 MTech projects, and 10 students are pursuing PhD. He is a member of the editorial board of Scientific Reports and Plus One, both Q1 ranked journals. Dr. Yadav has authored 50 research publications with more papers published in journals with an impact factor of up to 10.59. His research profile includes an H index of 23 and an I-10 index of 32 and more than 3,450 citations. He is ranked among the top 2% of researchers in energy as per the Stanford University World Ranking of Scientists and was listed in the top 2% most influential scientists in a single year in Stanford University's 2023 analysis of Indian researchers. He is also an active reviewer for various reputed journals. With this brief introduction, I request Sir to address the participants. Over to you, sir.
Okay, thank you, madam. Am I audible? Please confirm.
Yes, sir, you are
Yes, sir,
audible.
you are audible.
Okay,
And your slides
so
also visible.
so I would like to thanks Dr. Annam Ghosh sir and his team for invited me in this workshop. So in today expert talk, we will discuss about say forecasting of solar radiation using machine learning approaches. So in today content will be say basic of say solar energy and its importance, components and say measurement of solar radiation, challenges in measurement, need for prediction and its importance for Indian climatic condition. Then we will see deep learning models for solar radiation prediction. After this, we will see some say feature selection techniques. What are say different types of feature selection techniques which is important for solar radiation prediction? Am I audible? Please confirm.
Sir, you are audible, but your slides are not visible. Sir, can you please share your entire screen so it can be
So this
visible
one, sir,
properly?
visible. This one visible, sir.
No, sir, till now it's not visible. So any issues are there, you can also rejoin, no problem.
Okay. See. Now, sir, visible.
Yes, sir, it's visible.
Okay. Okay. So
Yes, sir.
after this, we will see say explainable artificial intelligence model in solar radiation prediction. Then we will see one say hands-on solar radiation prediction using say transformer neural network. This is a
Sir,
latest
can you please
model.
make it, sir, sorry to interrupt you. Can you please make it full screen, mane slideshow
Okay.
mode? So it will be better.
So
With.
that's okay. Okay, so so first we will see say importance of say solar energy is one of the most abundant and renewable sources of energy available on our planet. To give you perspective, the amount of solar energy that Earth receives in just 1 minute is greater than the total solar energy consumed by the entire population in whole year. Interest in solar energy really started to grow around 1970 when the cost of conventional energy sources begin to rise. For developing nations like India, solar energy is particularly say attractive because it is available everywhere, especially in remote or rural areas. However, to efficiently utilize solar power, we need to know one key thing: how much solar radiation is available at a given location and time. That's where solar radiation prediction comes into picture. Now we will see different components of solar radiation. First one say beam solar radiation. This is also called as a direct solar radiation. So this solar radiation reaches the earth surface without scattering. Then we are having this diffuse solar radiation, that is say that is sunlight that get scattered by cloud, dust and air molecules before reaches the surface. So this diffuse radiation we have seen in say mostly in say cloudy seasons. Then we are having this global or total solar radiation, which is the sum of both beam and diffuse solar radiation. So on this global solar radiation, our photovoltaic panels works, which convert this solar radiation into electricity. Then we are having some important parameters, uh, like say air mass. It tells us how much atmosphere sunlight passes through before reaching the surface. So when sun is directly overhead, the air mass is 1, which is and say angle, the path become longer and air mass increases. So understanding air mass helps calculate solar energy intensity at different times of days. Then how we can measure this solar radiation? So it can be measured by say instruments say pinometers and heliometers. So we are using this pinometer to measure say global solar radiation on a flat surface, while meters measures only direct beam components, uh, and this shaded pinometer we are using for measuring say diffuse solar radiation. So nowadays this measuring solar radiation accurately is not always easy, because when we have to say forecast the solar radiation or predict solar radiation, there we require say accurate measurement of say solar radiation data, because as we know that say this data is the fuel of say artificial neural networks. So in measurements, there are different challenges. We can say here, first measurement challenges are equipment limitation. Sensors like pinometers need regular calibration. Dust, tilt, errors or sensor drift, it causes inaccuracies. Then due to environmental interferences like cloud cover, aerosols, humidity make radiation reading vary significantly. Then due to geographical gaps in India and other developing countries, we have very few monitoring stations. As a result, it's difficult to get high resolution data for every location. Hence, instead of direct measurement, we often rely on models and predictions. So that's why what I want to highlight here, due to say limited measuring instrument across say different sites of India, so we require different types of say predictive models to predict solar radiation for say different sites, so that we can analyze or we can estimate solar photovoltaic power generation at that particular sites. Now, if we look these maps, so this is say a global solar radiation map of India. So what we see from this map, that this daily solar radiation is vary say around say 4.2, say around say 5.4 kilowatt hour per meter square per day. Um, per day. So so this is say this map is generated by say satellite measure data. So when we see satellite measure data, data it is measured say above atmosphere, above different layer of atmospheres. So that's why these maps are having overestimated values. So when we use these values in order to estimate say correct value of solar powers, it has substantial errors. So so when we see this map here, it is say photovoltaic power potentials. Though what we conclude from this map, this photovoltaic power potential is vary from say 4 4 4 to say 5.2 kilowatt hour per kilowatt peak. So what we can say here, that our country India is having say substantial solar power resources. Now we will see what actually solar radiation prediction means. So it means we have to use mathematical, statistical or AI models to estimate solar irradiance. That is amount of solar radiations so reaches at Earth surface, which is measured in so watt per meter squares. How how we can make this prediction? We we have to use several input features such as a temperature, relative humidity, wind speed, sunshine, cloud cover, and previous solar radiation data. By learning the relationship between these factors and solar energy, we can forecast future solar radiation value accurately. So, importance of solar radiation prediction for our Indian condition. Why it is important nowadays? As we seen, say, Indian climatic condition, it has a diverse climatic conditions. So we have say hot and dry Thar, Thar desert, humid coastal regions, and cold Himalayan areas. Because of this variation, accurate prediction of solar radiation become essential. With data-driven AI models, we can assess solar potentials at new sites. We can optimize panel tilt angle and sizing. We can improve grid integration and ensure solar power supply. Now, the government of India aims for say 450 gigawatt of renewable capacity by 2030, and solar radiation will be a key enabler for that goals. So, apart from this, when we see here, say solar radiation forecasting in different aspects, first, when we see here, say technical importance, it is used for say optimal design and sizing of solar PV system. It can be used for enhanced energy forecasting and grid management. Then if we consider this economic importance, say resource assessment and site feasibility studies, then it can be used for say techno-economic planning and investment decisions. Considering environmental importance, it can be useful for say climate and environmental studies. We can integrate with emerging technologies. So, what are different say challenges in solar radiation prediction models? First, we will see say traditional solar prediction models like empirical formulas or satellite-based estimates are limited. So these models are struggle with complex weather condition, incomplete data, geographical generation. This is where computational intelligence, particular AI and deep learning make a big difference. Now, now the computational method which we are using in say solar radiation forecasting, say deep learning models and say hybrid models, it combines a physical and statistical approach. Then we are using this time series forecasting techniques. Now we will see what are say deep learning models. So deep learnings is just a subset of say machine learnings. It is inspired by how the human brain work. It uses artificial neural network with many layers, hence the term deep. These models can automatically learn complex pattern from large data set without manual featurings. Deep learning has proven effective for time series prediction like forecasting solar radiation, as it capture both say short terms and long term dependencies. So when we try to see some very small difference between say normal artificial neural networks and say deep learning neural networks, so here we are having say input layers, and here we are having say one hidden layers, and here we are having say output layers. When we consider say deep learning models, here number of hidden layers get increases. Next, how we can say that deep
Uh,
learnings differ from
Sir,
say
can I
yes.
ask one question? One question. So
Yes,
this
yes.
learning happens on the data sets, right? So irradiation data, obtaining irradiation data all over India. The technology is matured, means already the data sets available.
So, sir, when we say, sir, data sets, okay. So nowadays we are having say satellite measured data for different Indian sites, okay. But when we compare this satellite data from say ground measured data, there is so much difference, right? So,
Okay.
here measured value of solar radiation data is not available for most of the sites in India.
Okay. So that means ISRO, the data, whatever ISRO is giving, so we have
Yes.
to have our own again data and then compare, right? Is it so?
Yes, because
Okay.
any ISRO is measuring with the help of satellite. The satellite is located say above environment. Okay, so so from say atmosphere to Earth surface,
Yeah.
there are say different layer of gases. Okay, so due
Right.
to reflection of solar radiation, so the intensity get reduces at the surface level of the ground. So that
Okay.
is the main difference. Okay.
Okay.
Okay, sir.
Perfect. Thank you. Thank you. Yeah.
Okay. So here we will see how deep learnings differ from say traditional machine learning. So here there is some difference considering say features engineering, say traditional machine learning, say manuals, so deep learnings here, say we can say automatic learn from data. So if we consider say performance big data, so in case of traditional it is limited, but in deep learning it is improved with data. Model complexity here it is shallow, but in say deep learning, deep neural networks with many layers. Computation requirement for traditional machine learnings, it is a moderate, but when we consider say deep learning, it requires a high value of say GPU. Considering interpretability, so traditional machine learning easy to interpret, but deep learning it is seen as a black box. But when we consider this application domain, so structure and tabular data, so here we can use say unstructured data, image in case of say this one say solar radiation. So 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 popular say deep learning architectures for say time series prediction. So first we will see say quick overview of say this basic ANN architectures. So so this ANN is the foundation of say deep learnings. It mimics the human neuron processing information. Each neurons receive inputs, process them, and passes the output forward. In solar radiation prediction, ANN takes meteorological parameter as input and predicts solar irradiance as output. Through training, usually using supervised learning, the network adjusts its internal weight to minimize error between say predicted and actual value. So this architecture has say input layers, hidden layers, and output layers. So in input layers, we used to give say input variables of say solar radiation prediction, or we can say that what input variable which affect the solar radiation prediction. So that input variable we have to take here. Now in hidden layers, there is a different types of say activation function, like say tensing model activation function, ReLU activation functions. After this, in output layers, uh, here we used to get the uh, results. So in output layers, mostly we have seen that they are having say linear activation function. So considering its mathematical equation, this here between say input layers and hidden layer, there is a different value of say connecting bits. again from hidden layers to output layer, there is a different value of say connecting bits. So if we see the mathematical equations, so it has a different inputs which is denoted by x1, x2 up to xn. There is a connecting bits. So here, this input corresponding inputs and bit, it get multiply and it get summation here. So when we will pass through this certain activation function, and it will comes like in this way. And this activation function, suppose we are using say sigmoidal activation function, again this will pass through that activation function. Again here there is a output, again it will say multiply, it's a connecting bits, and again in output layers we will get the say outputs. So here if we see here say how the whole process happening, so through input layers, then here bits, then here summing unit. After summing unit, there is a different activation function, and through activation function at here, there will be say error is calculated. That is a difference between say actual target value and say output value which is given by the network. So based on this error, again this updation of this bit take place. When the bit get updated, so that error get minimized. So on this process, this say ANN models which is working. So next one, here we are having this say supervised training. So in supervised training, just like say teachers are teaching the student in a class, and the student learn from the teachers. Uh, Again the teacher take the test, and so the marks, there will be some errors between say highest mark and lowest marks. So based on that error, again then student have to update their misperformance. In the same way here in supervised training, we have to provide both input and say target variables. The model compares its prediction with the actual value and calculated errors. So uh, usually we can use here say different types of error matrix. So mostly we are using this mean square error. So the error is then back propagated to adjust a bit. The process continue until the network achieves say satisfactory accuracy. So these are say different flows chart. So standard ANN solar ANN solar radiation prediction. So first of all, we have to take say database in solar radiation prediction. So first of all, we have to take say input variables and say target variables. So that's why here it is called as a database. Then we have to divide say database, means we have to take say 80% data for training, 20% data for say testing of say ANN models. Then here we have to develop the model. So here we are taking say basic model, say feed forward neural network, or say you can say that back propagation neural networks. After this, we have to select say different parameters so of the model. Then we have to train the model. So once we train the model, then we have to see how much means error that model is having, because that is called as a say error matrix of the model. So how we can evaluate the error matrix of the model? So first matrix we are using here: mean absolute percentage error, R square value, root mean square error, mean bias error, then R values, that is regression values. So based on this model, we will see how much error in that model is having. Suppose we are developing say say 2 to 3 models, and we will see the model which is having less error. Then so we can use that model for say prediction of solar radiation by putting some unknown values, unknown input variables. Now this is around say simple say predictive ANN models, simple ANN architectures. Then we are having say convolutional neural network. Suppose we have to use this satellite images, or you can say that certain value of image for say predictive part. So here we are mostly using say convolutional neural networks. So it is a type of say deep learning models which we are using mostly for say image processing. So it learn from say spatial hierarchies of features automatically. So major applications it includes say object detection, image classification, and segmentation. So when we see say architectures of CNN, here we are having input, then we are having say convolution layers, then here the feature extraction will take place, then we are having say pooling layer, then fully connected networks, then again here we are having output. Now we will see what are say function of say these say convolution pooling. So convolution layers, it extracts say spatial features of the image. Pooling layer, it reduces say dimensionality. Why reducing dimensionality is important? Because when we use say higher dimension of the data, okay, so in that case the error matrix will be more. Okay, so so once we reduce the dimensionality in the data at say pooling layer, so in that case we will get say error less. Then in this fully connected layer, it performs a classification. Then we are having activation function. So we are using this activation function to introduce a non-linearity in the data set, because if we use say most of the functions say linear, so it cannot handle the non-linearity which arises in the data set. That's why there is a activation function which uses say introduces non-linearity. Then we are having this loss function to calculate uh, the accuracy of that particular models. Now this is simple say particular say CNN's model for solar radiation prediction. As we have seen here, say input is in say the image form. Then we are having convolutional layers, then fully connected. Then here we will get the output. After this, this CNN, there is a recurrent neural networks. So how we are interested in recurrent neural networks? So it is a types of artificial neural network uh, which is used for say sequential data processing. Sequential data processing, because in say traditional neural network, what we have seen just before, uh, it has a input and say it has a input are independent of each other. But in say RNN, that is a recurrent neural network, it has a memory. But when we see here say basic say ANN architecture, it has not memory. So what will happen if this network has a memory? It consider both current input and say past data while making prediction. So why we require this RNN? Like say traditional neural network, like say feed forward neural network, it cannot handle say sequential data. Like when we have to work with say time series forecasting part, or time series say speech, or say natural language processing. So this RNN, that is say are effective in say time series forecasting, say text generation, and say machine learning translation. So we can use this RNN for say time series forecasting of say solar radiation. So what are say different application of this RNN in say different fields, say speech to text? Then we are having machine translation, which is very important to transfer one language into another language. Then we are having stock market prediction. Next here having text generation, then weather forecasting. So here when we talk about say RNN in a say simple word, like say imagine you are reading a sentence one word at a time, and RNN does the same. It look at the input one time step at a time. Example, 1 hour of weather data. It remember what it saw before. That is the important part. Unlike normal neural network, RNN carries a memory called as a hidden state. This memory stores what it learned from previous input. Each new input update the memory. When the next time step comes, the RNN mixes new data, say example temperature at time t, the previous memory information from earlier time. So the memory keeps getting update. It it learn pattern over time because it keep a memory, and RNN can learn time pattern like say solar radiation say rises in the say from say morning to afternoon. Temperature increases before radiation peaks. Wind speed changes slowly over time. Finally, it makes prediction. After reading a full sequence, say last 24 hours, RNN uses its finally memory to predict output solar radiation. So what we can say here, this RNN has a hidden state. So it is given by say this equation. Okay. So here we are having say hidden state at time t, xt at say input at time t, say bait matrix WH and WX are say bait matrix. Next B is the bias and F is the say activation function here. Here it has say tensing model activation function or ReLU activation function. So what we can say here, this RNN read data step by step, remembering past information. Based on past information, it updates its memory at every step, learn the time pattern, and then makes the prediction. So here what are say different steps which are involved in say training say recurrent neural network. So step one say forward propagation. So in forward propagation, this input uh, passes through the networks. So at each step, this hidden state updated based on current input and previous hidden state. The output is computed as a final state. Then step 2, there is a loss calculation, which is a difference between say predicted and actual value. It is called as a loss function. So mean square error for say regression task, and we are using say cross entropy loss for say classification task. Then back propagation through time. So similar to back propagation in feed forward networks, but applied over multiple time steps. So gradient are computed at each step and sum up. So these are say simple step when we are using this recurrent neural network for say time series predictions. Now there is certain say challenges in say recurrent neural networks. So first challenges what we can see in say recurrent neural network, it's a vanishing gradient problem. So this RNN forget thing too fast. Though this RNN has memory, but it forget thing too fast. Like try to remember what you ate last week, the memory fade quickly. Then second one here say exploding gradient. The RNN suddenly get confused during training, like your mind racing out of control, everything become unstable. Next one challenge is here say hard to learn long sequences. If sequence is long, means many time step, the RNN struggle to connect early information with later information. Like we can correlate this like say like reading a long story and forgetting the beginning. Slow training. RNN learns one step at a time, like reading a book word by word very slowly. You cannot skip ahead. Sensitive to wrong order. If the sequence is out of order or noisy, RNN get confused easily. Like say listening to a shuffle audio recording, the meaning breaks. Limited memory. So RNN can only remember a little bit of past, like having a very small notebook. Old notes get overwritten quickly. It is hard to tune, optimize, choosing the best setting, like say learning rate, sequential rate, hidden size is tricky. Like say cooking without recipe, you must guess the right amount of ingredient. So not good for say long-term pattern. RNN focus mostly on research, recent information and ignore older information, like remembering what happening yesterday but forgetting every events from the past. It cannot run steps in parallel, means it must processing step 1 before step 2 before step 3, etc. Like standing in a line, each person must be served one by one. And moreover, it is sensitive to noise and spike. If data suddenly jump or drop, RNN memory get disturbed. Like say try to stay focused, but someone keeps shouting uh, loudly. So therefore, to remove all these type of challenges, nowadays we are having this LSTM, which uses a gated architecture. This LSTM is called as a long short-term memory. It has a forget input and output to retain important information. So in LSTM, then we are having this gated recurrent unit. It is a simplified version of LSTM, but it is faster but effective. So now when we see the LSTM has a gated mechanism. It means it has memory cell maintain information over longer sequence, and it captures long-term dependency in the data. So it has say 3 gate. First gate called as say forget gate. Decide what old information to throw away. Like you can just correlate this like say cleaning your room, removing thing you don't need. Input gate, decide what new information to store, like adding information, adding important notes to your notebook. Output gates, here we are having decide what information to show the next at the current step, like choosing which note to read right now. So together these gate controls, this gating mechanism control what to remember, what to forget and what to output. So the LSTM keep the right information at the right time. So these are say simple architectures of this LSTM: forget gate, input gate, output gate. Then here we are having say different types of this uh, activation functions. So this LSTM here we are having input gate, forget gates and output gate, this PFC. So architectures say hidden states, then we are having this forget gates, then here we are having input gates. So each and every gate has a important function. So now why we are using this LSTM? So it overcomes a vanishing gradient problem of say traditional recurrent neural network. Uh, then it captures longer term dependency, which are say particular useful for tasks over longer sequences like say text generation, machine learning translation. Then here it is say flexibility, say LSTM can effectively learn what to retain, what to forget. So that's why this is very much it is highly adaptable to various types of say sequential data. Now after this LSTM, then we are having this attention mechanism. Attention mechanism, when we see here attention mechanism in say now nowadays most of the network are having say attention mechanism. So we will try to see the meaning of this attention mechanism by just correlating with say one of the simple example. Suppose we are reading a book, you don't read every single word with equal focus. So what is the tendency of the brain to to attend the most important part to understand the story? Similarly, in deep learning, attention mechanism allow allow models to focus on the most important and the most relevant part of input data instead of treating all information equally. So therefore, before attention, models have difficulty in handle longer sequence of data. But in attention, solve this by helping model decided what to focus on at each step. So what is attention mechanism? Attention mechanism is a method which gives a different weight importance to different part of input when making a decision or prediction. Analogy, so think of a student preparing for exam. So they will give more time to difficult topic and less time to easy one. Similarly, attention tells the model where to concentrate its effect. So what are different key features? First one says selective focus. It is helpful in model to for priority basis. Dynamic, the focus can change based on the tasks. Help bit say longer sequences like say paragraph of say time series. So how this attention mechanism work? Let us take one simple natural language processing. Suppose the model here, the cat sat on the mat and is generating the French word for cat. The model look at entire sentence and it gives a higher attention score to the word cat, lower to the irrelevant one like mat or on. So here what are say different say components say query queue, what are looking for, current word to translate, key, label for input data, value, the actual information of input. So this equation is used to calculate this attention. These formulas give weight to different part of input. The output is a weighted sum. One weight means more important. So now how this attention uh, was introduced in say deep learning. Now we are having say deep learning models say recurrent neural networks and LSTM. So initially recurrent neural network and LSTM were used for uh, handling sequences, but these had say poor performance on longer sequences, forget earlier word. So now this attention came into pictures. It was introduced in 2014 by Badhan ETL for neural machine translation. It helped model look at all word in the input sequence while generating each outputs. So this attention mechanism is developed by this group of person. So now in say 2000, this Google introduced say transformer neural network models in paper say attention is all you need, which only attention, no RNN or CNN. So what are say transformers in artificial intelligence? So nowadays here say transformers are say type of say deep learning models introduced in Google, by Google in paper attention is all you need. It handles say long sequential data like say time series without using RNN or say CNN. So this transformer models entirely looks on mechanism. It depend on mechanism say self attention, which allow the model to focus on different part of input simultaneously. At the same time, these models focus on different part of input simultaneously. So, so here instead of processing one by one like say recurrent neural network, what transformer models are doing, it look at say entire input at once using this self attention mechanism. So therefore, this transformer neural network, it revolutionized artificial neural network nowadays what we are seeing in say, especially in say time series prediction. So it can handle long sequences more efficiently than RNN or LSTM. It enables a parallel processing, faster training on GPU. So these are say backbone of say Chat GPT or BERT, which we are using in say Google search. Now, now at this time we have seen say different types of models, attention mechanism model like say transformer neural network model. Why it is important nowadays in say time series prediction or forecasting. Now the what how we can suppose we have developed the model, what are metrics we have to used for evaluation the performance of the model. So basically we are using this mean square errors. It is given by this equation. It measures average of square difference between observed and predicted. Then we are having root mean square errors. Here smaller RMS indicate higher prediction precision. Mean absolute errors, say average of absolute between actual and predicted value. So here R square value, how well um, prediction fit actual data. Then we are having mean absolute percentage error used for comparing performance across a different scale and say different sites. Now, so these error metrics we are using for calculating say performance of say different types of ANN models what we have seen just before. Now, here here again one most important thing, since suppose at this time we have seen that say different types of say models. Next come into the picture say very important part, that is the feature selection. Suppose when we are predicting the say solar radiation prediction, so there are different input variables which affect the solar radiation prediction. Now, if we use say all input variables, in that case, again, our this error matrix will be more. Then here the question arises um, how we can means reduce these errors. This we can do with the help of this feature selection techniques. So before training any model, we must decide which input to use, which input to use. So this process is called as feature selection. Why it is important? Because if we choose too many features, it introduces noise and slow down learning, while too few can cause loss of important information. In solar radiation prediction, like say key variables which we are using, like say temperatures, wind speed, humidity, it helps say improve accuracy, reduce overfitting, speed up training, and make model easier to interpret. So after this feature selection techniques, why feature selection technique is so much important in solar radiation prediction? So due to this important part, it improves accuracy, reduce overfitting, speed up training, enhance interpretability. Now, so once we introduce the feature selection techniques in say AI models for solar radiation prediction, then we are having say explainable AI, because nowadays when we made any say AI model, so we should have say proper justification why we are using that particular input for say prediction part. So therefore so at that time there this explainable AI came into pictures. So basically what is say explainable artificial neural networks? Explainable AI refers to method and tools that help us understand how AI model make prediction. Instead of just giving an answer, explainable AI tells us why and how the answer was reached. This is critical in solar energy prediction because decision based on AI model affect large scale planning, investment and policies. So what are importance of explainable AI? Explainable AI provide transparency. It allows engineers and say policymaker to trust model output by showing which factor influence the prediction. For instance, on a cloudy day, the model may highlight that cloud cover has a strong negative impact. On clear day, sunshine duration might dominate. Yet, explainable AI helps improve the model itself by identifying which input are irrelevant or redundant. So common explainable AI techniques. So first we have seen here say feature important analysis. We have to identify which input impact prediction most. So this is most important part. And then we are having this SAPly additive explanation. Quantifies contribution of each variable to a prediction. Then we are having this line local interpretable model agnostic explanation explain individual prediction locally. Then we are having say sensitive data analysis studies how output changes when input varies. So together these make model transparent and interpretable. So what are say different benefit of say explainable AI? So by using this explainable AI, we can achieve say greater trust and confidence in AI model, faster debugging and performance improvement, better decision making for grid operation and energy planner, and ultimately wider adoption of say AI technology. So, so here what we summarize say this solar radiation prediction, it play a key roles in solar power generation and energy management. Deep learning models like ANN, LSTM, and transformers models have significantly improved forecasting accuracy. However, without interpretability, their result can be seen as black boxes. So therefore, explainable AI bridges the gap, makes prediction transparent, trustworthy, actionable. As we move towards a sustainable energy future, combination of AI, deep learning, and explainable will be vital for developing intelligent, transparent, and reliable forecasting system. Okay, so these are some different say aspect of say solar radiation prediction. If you are having any question at this time, I am happy to take. After this, we will see one say implementation of this transformer neural network on a set of say input datas. We will see with the help of say lab session with the help of say Google Colab software. So till then, if you are having any question, you just ask to me.
Yes, sir. May I
Yes.
ask? Yes, you are talking about the big data, and
Yes.
the data you have taken, that is from ISRO SRR data or the NASA data?
Yes, basically this data is given by say National Aeronautical Space Administration. Okay, so that is a database which is freely available. So that's why I took that data because we are not having say time series measured value of solar radiation data. Okay, so that's why in today labs I am taking that data. Apart from this, I am taking that data which is measured by this Central Pollution Control Board, New Delhi. Okay, so they are also measuring say pollutant data, solar radiation data, wind speed data, relative humidity data, temperature data. Okay, so that data I will also take by developing this transformer neural network models. Okay.
Okay, sir. One thing is we have some ground data that you were talking about, that pyranometer and shaded
Yes.
pyranometer and
Yeah.
others. So
Yes.
actually we have implemented that, and we have, and it is definitely a time series data of a particular position.
Yes.
That is in our university. We have implemented that, and we
Yes.
have got the data. Now,
Yes.
the question is that this data, when we are talking, when we are collecting, there is some authenticity proof is required. That whether, because we are as observation, we are observed that some data is not correct. That we have cleaned, but the thing is. Different data when we are making it appended and trying to make the analysis of the data that you were talking, that it is maybe whether it is a statistical interpretation is required or the DNN model to be required. So how do I conclude or can guess that this model will be valid for us?
Okay, now you see when we say when you are telling say data, okay, so
Hmm.
you are having say measuring instrument, say pinometer installed at your institute to measure this data, right?
Hmm.
So so when you record the data, you will find out some data is missing. Okay, there may be
Hmm.
some outliers in the data, right?
Yes.
So
Yes.
yeah, so you can remove that outliers in the data by using say certain statistical tool like say box plot. Okay, so this
Yes,
type of
we
plot.
have done that. Yes, we
Okay,
have done that.
okay. So you have done this part. Okay. So
Yes.
once your say data is ready, right? Then
Yes.
on that data you have to develop the model, right? Okay.
Yes.
N-
Hmm.
Now you see for developing say solar radiation predictive type of data. For suppose you are having say basic ANN model which we are using say supervised ANN model, right? So
Hmm.
there you are having say target variable and say input variable, right? So
Hmm.
suppose input variable you are having x1, x2, x3, x4 or x5, right? Now
Okay.
here is your question that which input variable you have to take, right? Okay, am I
No,
clear?
no, not that. I am
Uh-huh.
talking about that which the input variable mostly we have taken from sensor, that is
Okay.
and the pyranometer data and the
Yes.
production also, that we have all the data we have. Now we have
Okay.
implemented several sensors so that real time series data of irradiation we have, and the time series data of generation we have, along with the and it is obviously DC. We have taken the current voltage and everything. Now
Okay.
we want to take the irradiation forecasting as well as the generation forecasting also for that
Okay.
irradiation. As a
Okay.
first part, we want to know that there are different model you are talking about, on also available in some literature. We have got that type of availability.
Yes.
Empirical model also we have seen. Now the
Yes.
theme Badescu we have written, that is also we have seen that empirical model. Now my question is, we have analyzed the data, but which model to be best for us? That either
Okay.
any machine
Okay.
learning model or
Okay.
the
Okay.
uh,
Okay. Okay.
hmm,
Now I understand. Now you see,
hmm,
uh, based on say different profile of the data, you cannot say that one model will give the say best result uh, on say different data sample, right? So
okay,
for this you have to apply say different AI models, right, whatever available in the literatures, and you have to calculate this error matrix for each and every models. Then you can say that this models is behaving good up to this error for this what data you have taken. Okay, you have
okay.
to do
That is
here.
depending on the error matrix, error
Yes,
calculation.
error matrix. I think here I have shown you this one
Hmm.
uh, this error matrix na? For each model you have to calculate all this error matrix. Okay, so so try to see which model is having less error matrix. Okay, so you can just clearly say that on this data this model is having less error matrix, so this model is suitable for this one. Okay.
Okay, and due to and the during the calculation of activation energy and weightage, that also, or there is any memory or that we have to calculate each time, and
Yes.
which formula or which kind of activation energy is required, that also can be given as and taken as a trial basis or
yes, activation. Now you see activation function. Okay, you are saying about
yes,
say
uh,
activation function, right?
yes,
So basically, when we consider this feed forward neural networks, okay, for say hidden layers, we are using say tensing model, right? Okay,
yes,
but when you say suppose you are taking say one hidden layer and you use say tensing models activation function, try to see. Okay, then you just take say two hidden layer, then three hidden layers. So when you gradually increase, okay, so one time will come, so the error will become more, right?
okay,
One
okay,
time will come, the error will become more, because what will happen when you are increasing the number of say hidden layer, the complexity also get increases. When complexity get increases, in that case model loses the generalization capability of itself. So that is the main important part. Okay.
okay, okay. So may we
Sir, may I ask
discuss
one
with you
question?
separately if there is your mail address or phone number can be during the time of if there is any discussion required, we may do
Okay.
that with you, sir.
Okay. Okay. Okay.
Okay,
Okay.
thank you.
Okay.
Sir, may I ask one question?
Yes. Yes.
So in actually the data sets, what we are observing is there are two different ways. Like you get the data and estimates for particularly for the irradiance to select a type of solar panel and the capacity. It gives very generic, like in the month of May, how much it would be, rather than the very realistic and this particular day and this particular time, right? So that data, that kind of the data, what we are generally getting from the ISRO, and the local generation data, what we are giving, may be the very specific and very realistic that time. So in general applications, the overall idea, like how this in a very abstract way, like uh, how much irradiance will come and how much, what is the capacity we plan, and then that need not be actually match with the present realistic time. Maybe today it may be 15 degrees or 20 degrees and tomorrow maybe 35 degrees. So the irradiance generally we look at it as uh, over a period of like an year, and how much the radiation is coming in that particular location in some kilometers or meters, like, and then on average rather than the very specific. So in that context, I'm just trying to understand that suppose if we are measuring the locally and then trying to match with the uh, abstract data what we are getting from there, and then it means what is exactly how our locally generated data will help in that, like, because in the variations will be too much, right? Because we are not taking average for
Yes,
a.
yes, it is happening in my case also. Because we have taken NASA data also, but almost similar in most cases. But in the NASA model, they
Mhm.
have done what I can give some highlights, sir. So
Okay.
that because I have compared this what you are asking, and that
Okay.
when we are taking Indian data, satellite data, and the local
Mhm.
microclimate, that we are talking about microclimating. So that
Right, right.
means
Yeah.
very specific region we have when we are taking and comparing those these data. Yes, in some region there is very stochastic or random variation, especially in June, July, August, like that, and
Yeah.
sometimes in the day basis also. But the thing is, that is why we are trying to make it, one is seasonal forecasting, not the forecasting yearly.
Yeah. Yeah. Yeah.
One
Yeah.
is monthly
Season
forecasting or
wise. Yeah.
seasonal forecasting. That is very important. And the second thing that you are talking about, that we are also trying, that is from the ground based data we are making a data, we are making a model, and from the NASA data, we are also trying to make the model, and the
Mhm.
error is sometimes it is very close to each other, but sometimes it differs because of this microclimatics. So in some spaces, NASA is also mentioned that they have trying to develop an assimilation model or called hybrid model, taking satellite data and 13 station they have already made from the Sandia National Laboratory and NASA data from USA. They have made it in their states or United States or some area where they have
Yeah.
taken the ground data as well as the satellite data, and combining these two they have made a
Right. Yeah.
assimilation or a hybrid model.
Perfect. Yeah.
That is very
And
good or effective, I think, will be best model for predicting the
Okay,
size and other. Yes, sir.
okay.
Amit, sir, am I correct?
Yes. It's happen actually. Why it is happens? Because when we look through this renewable energy sources, it is a stochastic variables, right?
Yeah. Yeah.
So when we say stochastic, so the variation will be more when we look through say 1 minute data and say 15-minute data and say 1 day data, right?
Mhm.
So so when the say variation is more, in that case we have to go for say different types of say data decomposition techniques. Okay, so once you applied say different types of say data decomposition techniques, like say empirical mode decomposition, assemble empirical mode decomposition, what is happening in say data decomposition techniques means so your data non-linearity will get reduces, right? Then what will happen, your data will close to the some linear types of behavior, right? So when we will put that say and that data using say empirical mode decomposition technique to AI models, in that case this one what you are saying about this error will get reduces, right? Because no AI model will give say accurate results, right? So therefore to reduce this um, error error matrix, we have to go for say different types of say hybrid model along with say data decomposition techniques, right? So you can say that when we use a feature selection plus data decomposition techniques plus say different types of say hybrid model, then in that case we are having this less error matrix.
Okay.
oh,
Okay.
Okay.
So
Okay.
yeah.
Thank you.
and this data decomposition techniques you will see yeah, you will find it most of the literatures. Okay, so always keep in mind this data decomposition plus feature selection. Okay, so when you are doing say for costing part, okay, so in that case we cannot use say less relevant variable. So that's why here nowadays this explainable AI came into pictures. Okay, we have to give say justification why we are using this particular input for the prediction of the solar radiation or say wind speed. Okay, so for this say for selecting say relevant features, so there are again say different types of method which is available in the uh, literature. So we have to apply this that method and see what is the effect of that particular input on say prediction accuracy of the models.
Okay. And
Okay.
it can be merged also. That means in some stochastic region, rainy season, if we apply this decomposition and this kind of mixture, and any other place, if we can take the same model, other model, maybe that can also be possible for
Yes,
different season.
yes,
Mm,
yes,
mm.
yes. For now, when you will see say different region, okay, so okay, in that case, your this data profiling will change. Okay, the method is applicable, right? Last thing is the
That
which
is
is just
spatial
say
variation you are talking about.
yes, yes,
For
yes. Once again. Yes.
For spatial variation at the same temporal point you are talking about, or
Mm,
it is the same point, same location, and the time series data?
No, 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 no. I am saying about say now when you will look about say Indian climatic condition, right?
Huh.
Okay, so our Indian climatic condition mostly divided into say 6 different zone mainly. Okay,
Mm,
so when you will look around say north side, okay, like say mountain areas, right? Then we
mm,
are having the central part of India. Here somewhat different. Okay, so
mm,
when we are having say different climatic condition or climatic zone, in that case, this is to uh, this solar radiation value also gets changed.
mm.
Okay,
Yes.
so so therefore, so when you will develop the same model, okay, so so you cannot say that means suppose we develop a model for mountainous area, then we have to check the model how much it is given for say other areas, right? Suppose when we are not having say sufficient number of say data sets. Okay, suppose when we are using say suppose when we are developing say data on this AI model for say particular zone, then we have to uh, uh, check it say accuracy how much it is given in at that particular area. That is the main important point.
Yes.
Okay.
Yes.
Okay, so apart from this, I want to show one say
So that means in a particular position, we have to develop first the temporal model, and then you have to check that for different spatial position, the how the model is how much close,
yes,
or if not closed, then we have
how
to.
much how much it is behaving, okay, how much
Yeah.
error your model is having, okay, just
Okay.
because we have to give say generalization capability of the model, otherwise what will happen, why this photovoltaic industry the people will use the model. Okay, so
Mm,
again,
yes.
this question will came in the mind. Okay, because another part is that we have to give say different set of data. Okay, it means diverse data to the model. Okay, so that the model can see say diverse nature of the data. So once the model sees a diverse nature of the data, so in that case the error will get reduces for say different climatic zone. Okay.
Yes. Yes. Thank you, sir. Thank you so much.
Okay. So apart from this, I am just want to show one say simple that how we can implement this say with the help of say Google Colab for making say BTech project or say MTech project or some PhD work. So here just for go on Google, here just write here say Google Colab. Here you will get say welcome to Google Colab, right? Then here you are having plus new notebook. Okay, plus new notebook. So here it will come. Here it will come. Here we can start this this coding, because here this Google this Python Google Colab is say enriching library. Okay, so I think we have to use this, and it can be run automatically. So when we compare this with the help of say MATLAB tools, okay, so MATLAB tools we require say license version, different types of, and it require cost. But here, what will happen in say Google Colab, it can be run easily on any system, and we can use say online part. Okay, so here we have to write this code. Okay, so we try to implement this transformer neural network model, which is mostly used by this in say chat GPT, or or in latest in some of the paper they are using this transformer neural network models for say prediction or say forecasting part. So first of all, we can keep the data in Excel part. So here for an example say, I keep a data set temperature, relative humidity, wind speed, and the solar radiation. And this data also say differ as per your say application. So here 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 I have put the code here. So so suppose here first of all we have to import the library. We have to import the library. So this is a important part of say this Google Colab. Just import the library for our say uh, particular application. So first of all, here we will see here pip this one. So install here say extra Python package in Colab. So um, this is used to say open PyXL, XLS, right, or XLS, because we have keep our data in Excel file. Therefore we have to write this standard code what we are having. Then we have to import and set up here. So here we are having say a different type of say uh, import standard utility like say hide warning message for a say linear log. Then here we have to import numpy, import uh, numpy as np, pandas as a pd, matlabplot.py plot as a plt. So numpy for array, pandas we are importing for say data frame, matplotlib for plot from google.colab import file. So so first of all we have to import all these libraries, because these our program require all these function. Next here we have to import um, this error matrix library. So therefore we have to write this one from say scalan processes import standard scalar, from scalan dot matrix import say mean square error, mean absolute error, r square. Then here standard scalar, it standardize features target the matrix compute mean square error, mean absolute error, and say r square values. Then here we have to import TensorFlow as say tf, import TensorFlow at say tf, from TensorFlows import keras, from TensorFlows.keras import say uh, layers. So load TensorFlows keras to build and train the transformer model, or you can say the transformer neural networks. Here here one term here that is a seed 42. So np.random.seed, here fix random seed, so your result are more repeatable. Because here suppose when we are taking the data, so the data will automatically divided into say training, testing. Okay, so how much data should be divided into training, testing? The same data should be divided when we run the program for the second time. So that's why here we are putting this command. Okay, so that this data, same data is splitting should be take place. Otherwise, what will happen? There is a random cases. Okay, in that case, again, you would say result will get different, right? So after this, then here we have to see, say, match time step to sampling. Then here we are having, say, time step is equal to 24. Say length of each input sequence, how much past time point the model sees. Then we are having, say, test size, validation size, 20% of data for test, okay, 10% of remaining for validation. Then here we are having, say, batch size, epochs, then learning rate, training batch size, maximum epochs, and learning rate of the optimizers. Then here we are having, say, transformer, dimension, model bit, attention head, feed forward size, and say dropout rate. Then here we are having, say, shuffle train is equal to false. Say do not shuffle time. Keep chronological order to avoid leakage. Then here we are having, say, then here train only on rows where, say, solar radiation which is greater than 20, approximate daylight, say, to reduce night time noise. So then we are having this target column RAW is equal to, say, solar radiation. Yes, sir. I am denoting with this yes, sir. Then here features RA is equal to temperature, humidity, say, wind speed. Then we have to name we expect from the target, and the three inputs here, say, case, oblique, spacing will be handled, say, later. Then we have to upload it, because we are storing the data in Excel, so we have to upload that data in this environment. So here the print, this message tell you what to upload. What to upload means upload CSV oblique XLS, because sometime our data is stored in, say, CSV format, and sometime it is stored in, say, XLS format. So here we have to keep in mind that which format we used to give to this environment. Then after this, then open a file. Then this one, say, then open a file, uh, this one, open a file pickers to upload your, say, data set. Asset len is equal to 1, upload exactly one file, ensure your uploaded one files. So F F name is equal to, say, here list, then print loaded. So get the uploaded file name and print it. Then here we are having, say, def read any part, low is equal to path.low. Then here it will help the help that read CSV or Excel with a fallback attempt. Then here df is equal to read any f name, here print data shape df.shape, display df.head. So here we are having, say, uh, uh, help the reader say CSV or Excel with a fallback attempt. So load your file into data frame, print rows into column, and show the first few rows so that you can identify uh, uh, whether what Excel file you are uploading, whether the correct data is coming or not.
The correct data means the data in the during the time of import, or it is the data which actually correct or not?
No, no. Now during suppose when you uploaded the data from Excel, okay, to this environment, right? So it will show you some few data, okay, from few data, so that it will confirm that your data is actually imported to this environment or not. Okay.
Environment means this Google
This
Colab
this
environment.
this Google Colab environment. This
Okay,
Google Colab.
okay, okay. So
This
that is
Google.
uploading the data from your site to Google Colab. That is
Yes,
authentically coming on.
yes,
Okay.
authentically connect.
And
Okay.
what is data shape here?
Here that is the part. Okay. So print data shape, it will it will give you, suppose you stored in data, say certain say column, okay, like say temperature, okay, wind speed, right? Okay,
Hmm.
wind direction. So it will give in that form,
Okay,
right?
that means row and column matching is there or not?
Yes, row and column
Hmm.
matching. Okay.
Okay.
Then we have to go for say normalization part. Okay. Normalize say column name and resolve say actual name. Why normalization is important in say machine learning model? So to bring it say between say to the say uh, standard range say 0 to 1. So these are say function which we are using for say normalization for. So function to make a column name standardized say lowercase no special tab. Here we have to create a map of original column name called as a normalized name. So basically these command, these special libraries which we are having for say normalization of say data samples, right? So here it will give you say give desired column name like say temperature, find actual column in your file.
So
This
that
first
normalization, yes, sir. May I ask
yes,
that
yes.
normalization is required for if there is the data value for different column is randomly changing, because that is to be normalized by every data, standard data, so that the maximum, the relevant like one, we normalize in experimental data like the value of that value, maximum value, so that it gives one in the highest mode. Whatever
Mm,
be the whatever be the unit, it can be dimensionless, and that kind of, is it like that normalization?
yes, yes. Normalization means because when we see say data, say it is in say different dimension, right? It is a different dimension. Normalization will bring your say data ranges between say 0 to 1. Okay. Okay. So once your say data is not in say range of say 0 to 1, in that case your this machine learning model will give you more error, or you can say that complexity will get arises in the machine learning model. So that's why we are using here say normalization part. So in each and every machine learning model we have to go for say normalization of the say data, right? Okay.
Yes, sir. Hmm.
Okay, right. So here all this all this uh, give you say in this format, right? Then here we will find out. Then here you will see here say different types of say target, feature, print features, print target. It resolves say real column name for say solar SR for solar radiation and for temperature, relative humidity for wind speed and printed. So it will get say differ as per your say application, right? Then we are using here optional say add calendar feature if a data time exists. So here dfc copy dt, here column is equal to none, work on a copy, start bit no data time column detected for c in dfc dot columns. If here say np dot issue data type. So if a column is already data type, data time type, remember it. Otherwise, try to parse a text column into say data frame. Then we are having say, here we are having say, if the if DTC is not none, then what it means? What it means here, suppose here we are using say bin direction. Okay, in most of the sensor we have to use say bin direction, because this bin direction influences the solar radiation. Therefore to convert, so bin direction will come in say degree, right? So therefore we have to convert it into certain say value. Okay, so like say cos theta, sin theta. So for this we have to use all this type of this function. Okay, next here convert hour and day of year into a smooth cyclic feature say sine cos. Then we are having say extra feature say hour sine, hour cos, day sine, day cos, and then we have to record name of extra feature or EMT. Then we have to build working data frame and basic cleaning. This one build working data frame and basic cleaning. So here num df, it will keep only numeric column, remove duplicate rows, drop rows that are say NA and value, because when we record the data, in that case there will be due to say sensor, then some value is not coming, or somewhere NaN is written. Okay, so if we put all those data, our machine learning will not work. There will be the error. Therefore, we have to put this command first, that it will automatically remove the NaN value. Okay, or it will or it will remove some duplicate row, because sometimes same row will come in the same Excel file. So we have to put this command, right? Next one say remove say negative solar radiation by value, cap extreme SRM spike at say 1100, adjust it if it get differ. Then we have to say final feature list is equal to here final feature list is equal to say temperature, relative humidity, wind speed plus optional calendar features. Then here keep only the chosen features and target, and drop any row with missing value. Now in Excel file we have seen that any missing row was there. Okay, so we have to drop it. So for this we have to put all this command in this environment. So after this, we have to print post clean shape, work shape, print engineer feature use all fit. Here shows resulting size and features use one if data set is too small for a chosen window length. Then we have to use say daylight only training optional. So it enables filter training pool to daylight row solar radiation above say threshold. Yes, keep all values, because what will happen, sometime uh, sometime the solar radiation value is very low. In that case, this command is neglecting that value. So as per our requirement, we have to put here certain say threshold value. Then here we are having this chronological split. Chronological split, what we are doing here, say function that cut the last part of for test and last part of the remaining for validation, all in other time check. Then if shuffle train or else train, okay, usually use chronological split. The shuffle option is there but not recommended. So here print this one, shows how many rows bend to each split. Then we are having say uh, scale features and target. So here x scalar, y scalar, what it means create standardized, say 0 means unit variance for x and y. Then we are having say x train, y train. Here we have to fit scalars on training only. Transform training features features target. Then we are having say X VAL, Y VAL. Here we are having same transform validation testing using the same training scalar. Then here we have to build sequence sliding window. Here we have to turn a flat series. This is related to say attention mechanism. Say turns a flat series into overlapping window of length time step. The label is the target at the last step of each window. Then after this, here we have to say say build a sequence for say training and say validation sets. Then show the sequence array shapes. After this we have to save number of feature and ensure we have some sequences. Then after this we have to go for say transformer encoder blocks. So basically this encoder blocks, say here we are having say multi head self attention on the sequence. X attend to itself, add and layer norm stabilize training. Here we are having feed forward network dense dropout dense. Then another add and layers norm return the transformer sequences. Then we are having this layer norms. Here we are having say model bit learnable say positional embedding. So here model input a sequence of length time step with n features step at each step. Then here you will find out one pros. It means project raw features to a transformer with D models. Then here we are having different types of say uh, positional encoding. Uh, so here create trainable positional embedding so the model knows. Add them to the projected. Stack two encoder bags. Then here we are having say pulls mm, the sequence across time into a single vectors average over time. After this here, then here we are having a small MLP head bit dropout final one output predicted SR in scale in unit. After this we are having this train. train means for this one, we have to go for say early stopping. If validation loss start, auto reduce learning rate. If plateaued, then we are having say this command here say. Uh, Here we are having say start training with validation monitor. So evaluate inverse scale. It help to convert scale value back to original solar radiation unit. Then here we are having get predicted on test sequence and scale both truth and predicted. Then here we are having say mean absolute values that won't divided by 0 unless tiny value of y is near to 0. Then after this we have to calculate and print the standard regression matrix. Calculate and print the standard regression matrix. We have to show test matrix for test made for the say daylight split. Then we have to reevaluate using the large chunk of full data set and evaluate all hours. Run the evaluators. Then here we have to do certain plot. Here we have to do certain plots. So a scatter plot of say predicted versus measured value with a data set reference line. So this is used for making the figure time series view of the last 300 test point comparing measured versus uh, predicted. Then we have to save the predicted value in say Excel file. Okay. So here create an Excel file with measured and predicted SR on say test data set. Then we have to save the models. Then we have to save the model, save the trade Keras model, predict on unknown rows and columns, say temperature, relative humidity, and say wind speed. Put your say new unseen rows here, just the three core input. So 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 this after putting all these here, so we have to run this part. So once we run this part, because it's just a transformer model. So here here I am getting say input in this way. Now you see here still I am not getting say correct by value, because this data seem to be close to these lines. Okay, so that is the main part. So therefore if we use here say empirical mode decomposition or certain decomposition type of techniques, then this prediction accuracy may get improved. So apart from this, I want to run this one. So here now you see here there is so much differences. Okay, but you can check it in our data set. It is given in this way. Maybe if your data is having say not so much non-linear, so in that case it may give you say good results. So okay, so here everything you will get here. And here you will get here say test matrix, say mean square error, root mean square error, mean absolute error, mean absolute uh, percentage error. So here again here we are having say test matrix, root mean square error, mean absolute percentage error. So by from this point we can run it. Suppose here we can run it, we can run this code. Here it will show the execution time. Here from this point we have to choose the file. Uh, from here I am choosing the data. Now see, this is the epochs, one complete sweep of say training, testing, and validation. Now the loss is coming low. Okay, now here it will come in the result. Okay, so that's all from my side. So again, if you are having some question, you can ask to me.
Listening participant, if you are having any query, please let us know. I have a question. Can you change the
Yes, sir,
font size
you
of
have
this
nicely
genetic box?
described. The thing is that ultimate the result that you were last you were showing, that
Yes,
is the predicted one is the linear, almost following the linear model. But
yes, yes.
the original data is non-linear kind of thing in your scatter
Okay,
plot. So
okay.
in that,
So okay. Yes, yes. Go ahead.
uh, then the prediction is far away. I think it
Yes.
is not actually giving the correct result till now.
Yes. Actually, what will happen here? So you can take this say transformer neural network, right? Implement in your study. Main purpose of showing this one
No,
because
you
it's
are
a
showing that this is the normal conventional model. It is not the transformer
no,
model
no,
you
no,
are.
no, no.
Mm.
It's a transformer model. Okay, it's
Okay.
a
Uh,
transformer neural network model. You can take
okay.
this model. You can use in your study, right?
Okay.
See how you are getting the result. Okay, because here I am using say around say 200 data samples. Okay, maybe you are having say less data sample or most linear or most some good say data sample value. So in that case you might you may get say good result. Okay, so you can
Okay.
use in
You are
your
telling that it is not of your big data. So maybe
yes,
the number
maybe
of data is affecting here. Maybe,
yes,
maybe.
maybe
Or
maybe
maybe the
number of
features you are selecting that
yes,
maybe.
and that may be effective. So main purpose of showing of this model, that is transformer neural network model, because whole say this chat GPT model, so they are working on say and they are using this transformer neural network model for say natural language processing, right? So you try to use this model in your study. Okay, so definitely it will benefit you a lot. Okay, apart from this, you can use some say data decomposition type of technique here and you will get the result. Okay, because this is say this doesn't require any this Google Colab. It doesn't require any software. It is provided by say Google. You can run it in your own system online and get and see what you can do. Okay.
Okay. Okay, sir. Thank you, sir, for your nice lecture. And hope we can collaborate some of the work if it is possible. Uh,
Okay.
uh,
Okay.
mm,
Okay,
okay.
madam.
Okay, sir.
Okay.
Thank
Okay.
you.
Sir, I have one question. Sir, can we change the font size of label for generated plots?
What? Again?
Can we change the font size of labels for generated plot? Suppose I want to change the font size.
Yes. Here I have to see certain command we have to use. Okay. For are you saying this font size, ne? Font size, ne?
Suppose
Font
font
size.
size X label for X label, so I want to edit the font size.
Yes. It can be changed. It can be changed. Here, na, you are saying the font size of this one. Okay. Font size of this
Yes.
one. It can be changed. Not a big issue.
May I ask you one question, sir?
Yes.
Sir, you have implemented to forecast the system input side. Can we use this for the to control the output or regulate the output of converter?
Output of the
Converter.
converter. Now you see. Uh, First, let us see why we are using these AI models. Okay, right. So I am not working on say converter size, but what knowledge I am having here. So because your this converter model has a equation. Okay, so based on equation, if you are getting the result, okay, you are getting the say accurate result. Suppose you are putting say 2 and you are getting what you expected. Okay, then no need to use this model. Okay, because
Yes,
because
yes, sir.
that is the case of say hard computing. If your hard computing is giving accurate result, then no need to use this soft computing techniques. Right. Here we are using this soft computing techniques where these hard computing techniques get failed. Right, why we are interested in this type of neural networks? Because when we will use this traditional method of equation like say y is equal to mx plus c, or when we are using some say higher degree of equation, in that case we are getting more error. So that's why we are interested in using this different types of AI models, right? Apart from this, here in AI models, your input is varying with respect to the time, right? Because it's a renewable energy sources is the stochastic variable. So input is variable with respect to time. So output is variable with respect to time. Apart from this, what input we are giving to the model, that input is also interdependent to each other, right? Okay, so that is the main task here. So you try to see whether you are having any base paper which they are using this ANN model, then you can use it. Okay.
Okay, sir. Fine. Thank you.
Okay.
Sir, in the context of the hard question, may
Yes.
I add one important, maybe it may help all of
Yes.
us, that
Yes.
if he is talking about controller and the PWM is very much required during the time of controller, and it is the delay or the time on and off and other things. So controller, if it is real time controller, if you can design that, taking the forecasting of, considering the forecasting of the accurate irradiation and the forecasting of the production, if we know a priori and change our timing duration and the controlling part accordingly, for load demand and others, then I think it may be used for a kind of intelligent controller, for making an intelligent controller real time. We may,
Yes, ma'am.
we may
Yes, ma'am.
take this. No, no, ma'am. Maybe it will be helpful for that.
Yeah. Yes. Yes.
Mm. The controller will take the considering the prediction, it will take the changes of its pulse width, and also the converter itself, when it will go to the which converter. Maybe sometimes it goes to buck converter, sometimes boost, and sometimes maybe Kalman, like sometimes may require that filter is required. So we don't know, but if prediction is on a hand, then we can accordingly our controller can control the system.
Yes,
That may
ma'am.
help
Yes.
us in
Yes,
future.
yes. Sure.
No, thank you, sir and ma'am.
Okay, thank you, Professor. So I think most of the queries has been addressed by that Professor Amit Kumar Yadav. I think there is no other query. Thank you, sir, for your beautiful session, and a lot of interaction happened in this session. That is very good for the participant aspects. Okay, and your presentation was really nice, as well as you are showing a lot of simulation in Colab. Okay, so all can relate the real-time issues and how to incorporate data, plotting of the data, and the predictions of these things. Thank you, sir, for giving us your valuable time. And again, we can conduct some of the workshop, and definitely we can even invite you.
Oh.
Thank you, sir.
Okay. Okay. Thank you, sir.
Sir, may we get your mail address and if it is
Okay.
if it is
Okay. Okay. Shall I write here?